Go. All right. So again, as we are doing this, please make any corrections on it. Okay. If you did it in pencil, correct it in like pen so it stands out. Don't correct it in the same color that you wrote on, because again, your corrections won't stand out and you're going to end up studying the wrong thing. So the very first thing, it says write an equation with the given description. It may help you to sketch a graph to confirm your answer, but you don't have to do it. So, but what we have to do in the directions is this. So every answer should be in y equals mx plus b form, correct?
Yeah.
Yeah.
All right, so we're given 2 points. If we're finding the slope, because that's one of the things we need, of 2 points, we got to use our little formula. So 13 minus 9 and 5 minus 0, and it's 4/5 is the slope. Okay? Now, look at this point here. The 0 is in the x spot, which means that they gave us the y-intercept. That was awful nice of them. So we have the 2 things we need to write our equation for number 1. Y equals 4/5 x plus 9. Okay? Nice, good one to get it warmed up with. Okay? Number 2 says we have an undefined slope through the point 1,4. What do you know about when you see the word undefined slope? What kind of line should you be thinking about right now?
Vertical.
It's a vertical line, right? And all the vertical lines go through the x points, right? So remember, we have a special equation here. So in our coordinate here, where is the x value?
1.
Right. So x equals 1 is our equation. Because all the points, all the x points are 1, the y values would change. So remember, we did that special when we did the notes on horizontal and vertical lines. All right. Now the next one, they don't give us a y-intercept. So we got to kind of go from scratch here. We got 2 points. So we'll call this one 1 and this point 2 to find the slope. All right. So let me I need all the space I can get here in this little area. So y2 minus y1 over x2 minus x1. So 9 minus 1 and 4 minus 1. Well, 9 minus 1 is 8 and 4 minus 1 is 3. So there's our slope. So what happens to us when we're not given the y-intercept? What do we have to do? Who remembers? What process, Joanna? What process do we have to go through to find the y-intercept?
You use the equation y equals mx plus b, and then you put in one of the coordinates into it.
Right. I'm going to plug a coordinate into y equals mx plus b along with the slope, because I'll be able to get y, m, and x, and we solve for b. So let's use 0.11 just because the numbers are smaller. All right. So 1 goes in here, 8/3 goes in here, times 1 plus b. So this becomes 1 times 8/3 is just 8/3. All right. And to make things easier for us right now, let's take 8/3 and make it a decimal. So 8 divided by 3 is 2.6 repeating. So to get b all by itself, what do I got to do? How do I get b all by itself?
Subtract 2.6.
Right, I'm going to subtract 2.6 repeating to both sides. Okay, so that's gone here. And I'm left with b equals, well, 1 minus 2.6 repeating is negative 1.6 repeating. So I got my y-intercept and I got my slope. Now, I know that 0.6 repeating is what fraction?
Improper.
Well, it is improper, but the decimal, 0.6 repeating is what fraction? Anyone know?
2/3.
Right, 2/3. So if I take this mixed number and write it as improper fraction, it would be what? Remember how to do that?
5/3.
What was that? That was faint, very faint. I couldn't hear that.
5/3.
Not 5/3, because we got a negative here. Negative 5/3. Because remember, 3 times -1 is -3. And we got to add 2. We got to move it down 2 more. So, yeah. So it's negative 5/3. So we have our y-intercept. We have our slope. So you could write this 2 ways and be right. You could write this way with both of them being fractions. Or you could write it this way. Either one is correct. Try to stay away from the slope being a decimal, because again, you can't see rise over run. I will tell you this, I can promise you this, I bet my paycheck on this. In high school, you will get it marked wrong. So try to learn to keep your slope the fraction, whether it's a regular fraction or improper. All right, number 4. Number 4, we kind of got the same problem as number 3. Joanna, do you still got a question?
No, sorry.
Okay, no, that's okay. I just want to make sure. I didn't want to go on without someone with it being stuck. So we got kind of the same thing as number 4, except the numbers are a little bigger. So that's the only difference. So let's find the slope. y2 minus y1, so 8 minus 7. And x2 minus x1 is 6 minus 5. Ooh, this works out nice. 8 minus 7 is 1. 6 minus 5 is 1. And 1 over 1 is 1. Wow, that was nice of them. All right, now, because I'm kind of low on room here, I'm just going to work left to right. So I'm going to take the 0.57 just because its numbers are a little smaller than 6/8. So 7 is the y, 6, I'm sorry, not 6. I looked at the wrong point. 5 is your x, and 1 is your slope. Okay, so 1 times 5 is 5. And I subtract 5 to both sides to get my b all by itself. And b is going to equal what? 7 minus 5.
2.
2. So I got my slope of 1, my y-intercept of 2. I don't have to write 1x. I can just write it like that. And there's my answer for number 4. So that wasn't as bad as it looked, right? Now, number 5, we got another different scenario here. They gave us the slope. So we have that information off the bat, which is nice. They gave us a point. So all we need to do is plug into y equals mx plus b, the slope and the point, and find out what our b is. Because this coordinate doesn't have a 0 in the x value, so we have to find it. So 3, that's y. The slope is 4 times -2 plus b. Well, 4 times -2 is -8. And I add 8 to both sides to get b by itself. So b is going to equal what?
11.
11. 8 plus 3. So we have our slope. We have our y-intercept. That turned out to be nice and easy. Okay. Now number 6 is again extremely similar to 5, except now the slope isn't a nice whole number. It's an improper fraction. Well, that's all right. Put a 7 in for y. The slope is 3/2 times 4 plus b. So when I multiply 4 into 3/2, remember, we always multiply a whole number or an integer into the numerator of the fraction. So 4 times 3 is 12. It's 12 over 2. What does 12 over 2 reduce to?
6.
6. So I subtract 6 to get b all by itself. And b is going to equal what? 7 minus 6.
1.
1. So our equation for this one will be y equals 3/2 x plus 1. Plowing right through this. All right, now we got 2 points again. So we're going to find the slope first. Watch what happens. 8 minus 2. That's your y2 minus y1. And 1 minus 1. I get 6/0. Uh-oh. Who remembers what happens here? What happens when we have a 0 in the denominator? What kind of line are we talking about here?
Undefined.
Very good, undefined. It's a vertical line when the 0 is in the denominator. So if our slope is undefined, what do you notice about the points in the 2 points? Do you notice anything about the 2 points? Emma? Oh, I'm sorry, that's Fiona.
They're both 1.
Yeah, they both have x values of 1. And if it's an undefined slope, it's what all the x values are. There's your equation. And then 8, after finding out points and this and that, 8, they give us a graph. This is the line right here. That is what kind of line?
Horizontal.
Horizontal. What kind of a slope does a horizontal line have?
0.
0.
0, right? And the equation is whatever all the y points are. And the y values are what? On this line.
-5.
Yeah, right here. So there's your equation. You don't write the 0x in, right? You would not write this. Right? We don't need that. We don't need that part. All right. So that was the first 8. Just by raising your hand, anyone get the first 8 right? How about, okay, couple, how about 2 wrong or less? So if you got 0 wrong, keep your hand raised. Let's see what adds to it. Okay, quite a bit. Good. And again, I hope you're making these corrections, okay? Because this whole thing is designed to help you, give you a great study tool for tonight. So it says here, with the given graph, we have to find the slope, the y-intercept, and the equation. So on my line here, I got to find a couple points. Well, they give us a couple points, right? Here and here. Well, this point happens to be the y-intercept, right? What is that coordinate?
-4.
0, comma.
No, not -4. That's over here.
+4.
Nope.
+3.
Yeah, this is 0, 3.
Oh, you see that?
So that's our y-intercept. This is our x-intercept over here. Okay. Now, we got to find the slope. That means we go rise over run. Well, rise, we have to go down 3 and over this distance, right? So if we go down 3, what number is that?
-3.
Right. How far do we go over?
4.
Right. So our slope is -3/4. So we have our 2 things we need to write our equation of this line as that. All right. First page done. A lot of busy work problems on this page. Now we'll get going. All right, we good to go?
Yeah.
Okay. Oh, a little sensitive there. All right. So you received an iTunes gift card for $50. The songs cost $1.29 each. Okay. So you can tell this test was written a little long because I think they're a little different now, right? Aren't they a little bit more expensive? Or Obviously, depending on what you buy, are they still $1.29? Does anyone even buy iTunes songs anymore? But anyway, they give you the equation. That was nice. So it says, if you have a balance of $13.88, how many songs have you purchased? Well, X is your number of songs and Y is your balance. So if our balance is $13.88, we're plugging that in for Y to solve for X. Okay. So if I subtract 50 to both sides, because I got to get the variable by itself first, right? And I got my trusty calculator with me here. So 1388 minus 50 is negative 36.12. And I got to divide both sides by negative 1.29. I got to divide the number by itself for it to get to 1. So negative 36.12 divided by negative 1.29. What do we know what happens when you take a negative and divide it by a negative?
Becomes positive.
It becomes positive. And you get 28 as your answer. So our answer becomes 28 what?
Songs.
Songs. Very good. That's how many you had to buy for you to have a balance of $13.88 left on your card. Okay. The second scenario, so you're taking a cab to the airport. The ride costs 40 cents plus 15 cents per mile. So they even gave us the equation again. Again, awful nice of them. All right. So X is our number of miles that we traveled, and Y is the cost of the trip. So if the trip cost $8.65, how many miles did you travel? Well, we're going to plug $8.65 in for Y, and we're going to solve for X. So the first thing I got to do is subtract 40 cents. And I get $8.25 here. Okay. And to get X by itself, I got to divide by 0.15. That becomes 1. And when I do that, 8.25 divided by 0.15 is 55. So our answer here is 55 what?
Miles.
Miles. Very good. 55 miles. All right, moving down. So now we got a question here with a graph. Now I know the points don't look straight, but they are, okay? So it is a linear model. It's a very crummy linear model because it's very tough to do in Word if you've never done it. So Samantha received some money for her birthday and put it in the bank. Since her birthday, each week she puts part of the money she earns from babysitting and doing chores into the account. The graph shows that after 2 weeks, she had saved a total of $144. That's this point here. And had saved a total, and after 12 weeks, she saved a total of $244. So the first thing we got to do is find the slope of a line. Well, we got 2 points here, right? Because we really don't know the coordinates of these coordinates, right? So you really can't do rise over run here. I mean, I guess you could do it to the big ones, but let's just use our slope formula, right? Y2 minus Y1, and then X2 minus X1. So 244 minus 144 is 100, and 12 minus 2 is 10. And that works out nice, because what does 100 over 10 reduce to?
10.
I wasn't expecting that long of a pause. What does it reduce to?
10.
10. So there's our slope. So what does the slope mean in terms of the context of the situation? She saves $10 per week. Then it says, what would the y-intercept be? Well, again, since we don't have it on the graph, we could pick a point and plug it in, right? So let's use the first one, 144. So if we were to plug 144 in for y, 2 for the slope, and 10, I'm sorry, that's wrong. 10 for the slope, because that's a slope, and the coordinate is 2 for x. 2 times 10 is 20. And to get b by itself, I got to subtract 20. So b is, what's 144 minus 20?
124.
124.
124. So it says, what does the y-intercept means in terms of the context of the situation? Well, $124 is what she put in the bank. Or you could say that's the money she got for her birthday. It's the starting point. Okay, there's page 2. Let's go to the back because now we got to combine it, right? The back says we got to come up with the equation now. Well, we got our y-intercept. We got our slope. So we got everything we need. Okay, it says write an equation to model the relationship. Well, the equation is that it says you can use the points in the diagram to verify if your answer is correct. So if you plug 2 and 144 in here, 144 for y and 2 in for x, if the left side equals the right side, we did it right. And if you look at it, it checks. So we know we have the right equation because if they always, all the points would have to check if they're on the line. If it doesn't check, it's not a point on the line. All right. Moving on to a different scenario now. A hippopotamus was born at the Cincinnati Zoo. As she gets older, her weight increases. The graph shows that after 2 years, she weighs 1,300 pounds. And after 10 years, she weighs 6,100 pounds. So again, very, very similar scenario to the first one, right? So we're going to use our points to subtract. y2 minus y1. We just got bigger numbers is all. And then x2 minus x1. So 6,100 minus 1,300 is 4,800. And 10 minus 2 is 8. And 4,800 divided by 8 is 600. So 600 for the situation means that the hippo gains 600 pounds every year. That big hippo. Okay, what would be the y-intercept? Well, again, let's pick a point. The smallest point that we're given is 1,300. So we're going to plug 1,300 into y of y equals mx plus b. We're going to plug 600 in for the slope and 2 in for x. And 600 times 2 is 1,200. So when I subtract 1,200, 1,300 minus 1,200 becomes 100. So our y-intercept is 100. And that means that basically at birth, the hippo weighed 100 pounds. So if we got to write the equation to check it, Well, number 17, we found our slope. Number 19, we found our y-intercept. So just plug those guys in there. And again, if we plugged in a point to check it, okay, we can plug in we can put the second one in there just so you can see it. 600 times 10 plus 100. That's 6,000. It's 6,000 plus 100 is 6,100. So you can see that it checks. So you know that this equation is correct. All right, and just like that, with 7 minutes left of class, we got the back page. We're going to finish this easy. How we doing so far? We doing okay?
Yeah.
We're keeping up all right?
Yeah.
Okay, good. All right, table below shows the weights for several different bunches of bananas. Use the table to answer the next 2 questions. Explain or show or explain your process. So estimate the weight of 7 bananas. Well, we know that 7 is somewhere in here, right? Can we agree with that?
Yeah.
Yes.
All right, so what we can try to figure out is the weight depends upon how many bananas there are, right? So this is your y, your dependent variable versus your independent variable. So if you notice, this is increasing by 1 here, and this is increasing by 5. Where over here, this is increasing by 5.5. This is increasing by 5.5, and this is increasing by 27.5. Well, we know we have 2 ratios here, right? We have 5.5 over 1, which is 5.5, and 27.5 over 5. Anyone know what that is? Anyone want to take a guess? Or anyone figure it out? All right, I'll let the cat out of the bag. It's 5.5. So we actually have a constant rate of change in the slope. So if we know what the constant rate of change is, the weight's going up every 5.5 ounces for every banana. That's 7 bananas. Just multiply it by 5.5. And you would get 7 times 5.5 is 38.5 ounces. So just by finding that little bit of information first, made our life a whole lot easier, right? All right. Estimate what the number of bananas for the weight. Well, if our slope is 5.5, right? What would our y-intercept be? What would be our weight at 0 bananas?
0.
0, right? So our actual equation for this, isn't that the slope, right? Is that. So if we want to know what 50 ounces would be, take 50 and solve for x. Divide by 5.5. That becomes 1, and 50 divided by 9.5 is like 9.1. So again, if you wanted to estimate it, you could say that, or you could say about 9 ounces, or 9.1 ounces. Because again, it doesn't tell you the y-intercept, but again, you know just from real life, if you don't have anything to weigh, it doesn't weigh anything, right? I mean, that's just common sense. All right, let's go to the last one. The table shows the thickness or number of layers of a bridge and the breaking weight in pennies. So we're going to use this table to answer the next 2 questions. So again, if we take a look, it's kind of like the other one, right? This is going up by 1. This is going up by 5. This is going up by 14, 14, and 70. So our breaking weights Well, we know that 14 over 1 is 14. What about 70 over 5? What's 70 over 5? Anyone got a calculator handy? Anybody? 14, very good.
14.
So there's our slope. There's our constant rate of change for this. Every time we increase the thickness by a layer, it takes 14 pennies or the weight of 14 pennies to break it. So for 14 layers, you just take 14 layers. We know that the weight is 14, right? 14 times 14 is, that's how many pennies it takes to break it. Because again, if we don't have any thickness, there's no pennies to break it, right? So basically our equation here is that. So if we want to estimate the number of layers, if the breaking weight is 112 pennies, you plug in 112 for y and solve for x and just divide by 14. So just by finding the slope, we were able to figure out all this information. Well, 112 divided by 14, see here, does that come out even? It does. It comes out to 8. So the answer is 8 what?
Layers.
8 layers, right. It would take us 8 layers for the 112 pennies to break it, according to this chart. All right. And that is the quiz with 2 minutes left to spare. So let me come back here to the computer and we'll stop our recording first.